Solving systems by graphing. Our objective is to identify solutions of systems of linear equations in two variables, as well as solve systems of linear equations in two variables by graphing. Why learn this? You can compare costs by graphing a system of linear equations. Let's start with some vocabulary. Systems of linear equations. A set of two or more linear equations containing two or more variables. Basically, it's two equations. Like you had y equals mx plus b. Well, it's putting two of them together. The solution of a system of linear equations is an ordered pair that satisfies each equation in the system. So it's the ordered pair that works for both the equations. So let's practice that part. So we need to tell whether the ordered pair is a solution of the given system. So you have an x, y coordinate. So we're going to substitute our x and y values in. So for this first equation, we're going to have 4 plus 2 times 1 equals 6. But we need to see if it actually does equal 6. So 4 plus 2 equals 6. We're good to go. Let's try this next one. 4, since that's our x value, minus 1, since that's our y value, does that in fact equal 3? Yes. So therefore the answer is simply yes. Let's try this next one. Once again, we have an x, y coordinate. So we're going to plug in our x value and our y value. So we have 2 times negative 1 plus 5 times 2. And we want to see if that in fact equals 8. So we have negative 2 plus 10. Yes, that does equal 8, so we're good to go. Let's try this next one. So we have 3 times negative 1 minus 2 times 2. Does this equal 5? Well, we've got negative 3 minus 4. That does not equal 5. As soon as one of the equations or the functions can't be satisfied by the coordinate that you're trying to either find or the coordinate that is given, it's not a solution. This is not a possibility because it didn't work for the second one. It has to work for both of them for it to be a solution. So the answer is no. Now let's practice graphing to find out whether or not that solution that we are looking for is in fact the solution. So let's start by putting this one here in slope-intercept form, our first equation. So we've got 2y equals negative x plus 6, because we moved the x to the other side. And now we're going to divide by 2. So we have y equals negative 1/2 x plus 3. So now let's graph that one. So there's our line for the first one. And now let's do the same for the second one. The second one we'll do in pink. So we've got negative y equals negative x plus 3, because we moved our x to the other side. And now we need to divide by negative 1, or you can think of it as multiply it by negative 1, so that y is by itself. So we have y equals a positive x minus 3. And now we'll graph this one. So just as it described here, where the two lines intersect is the solution. So the two lines intersected at 4, 1, so that is the solution. Alright, so now let's try solving a system of linear equations by graphing. So just like in this example that we had here, where the two lines intersect is your solution, this time you're not given your solution, you need to find it. So let's graph both functions. The first function will be graphed in blue, and the second one will be graphed in pink. So the two functions or equations intersect at the point 1, -2. So the solution that's going to work for both equations is 1, -2. Let's try this next one. To do this next one, keep in mind you want to be able to graph this, so it might be easier to graph it if you put it in slope-intercept form. So for this first one, it will once again be in blue. We're going to have y equals -x, and well, plus 0 if you want to put it in there. And our second equation will be graphed in pink. So take a moment and graph both equations. Alright, so both are now graphed, and where they intersect is at -2, 2. So that is the solution that satisfies both functions. You can do this on your graphing calculator as well. If you want to learn how to use the graphing calculator to graph both of these and find the intersection, talk to your teacher. So let's conclude the video with a problem-solving application. Bolorama charges $2.50 per game plus $2 for shoe rental, and Bowling Pins charges $2 per game plus $4 for shoe rental. For how many games will the cost to bowl be the same at both places? So if you want to figure out where it will be the same, when we graph, it's where the two lines will intersect. So step 1, we might want to write two linear equations. So we'll keep our format here, and we'll do blue for our first one. So Bolorama is going to be in blue here. So it's $2.50 per game. So y equals 2.5 per game, there's your x value, plus our $2 for shoe rental. And our next function, we'll put that one in pink. We've got y equals $2. So Bowling Pins charges $2 per game plus $4 for shoe rental. So we're going to find the solution by graphing both of these equations. So take a moment and graph them out. Alright, so both are graphed, and where they intersect will be our solution. And they intersect at 4, 12. So the cost at both places will be the same for 4 games, and that cost will be $12. And that ends our video on solving systems by graphing.